problems. And it simplifies model development by automating tasks such as data pre-processing and model selection and hyperparameter tunings. And key components of AutoML processes are data ingestion and pre-processing. And in this data ingestion and pre-processing, input raw data from various sources and handle missing values, categorical encoding, normalization, and feature engineering automatically. Ensures clean and meaningful input for modeling. And feature engineering like automatically creates new features or selects important ones to improve model performance. Can include dimensionality, reduction, or transformation techniques. Model selections searches among a variety of algorithms, example decision trees, neural networks, SPMs, uses strategies like ensemble methods to combine models, hyperparameter optimization, tunes model parameters, example learning rate, depth to maximize accuracy, uses methods like Bayesian optimization or random searches. And next is training and validation. In this, trains candidate models on training data and also validates performance on validation sets to avoid overfitting. Model evaluation and selection compares a model based on metrics, accuracy, FM score, etc., and selects the best performing models. And deployment and monitoring deploys model to production, monitors model performance on new data, triggers retraining if needed. AutoML in applications enables AI practitioners to build models quickly with extensive uh, ML expertise. And common in industries like healthcare, disease predictions, finance, fraud detection, and detailed demand forecasting. These are the normal industrial commons in industries, what is happening in those industries. And compatible with cloud services like Google Vertex AI and Azure AutoML and AWS SageMakers, these are the AI platforms in different cloud platforms, Google, Azure, and AWS. And in summary, like we can say, AutoML streamlines machine learning workflows by automating complex and repetitive tasks, and it key components works together to optimize model performance efficiently. And next one would be the detailed one. So I will show you just workflow in that. So in this, the standard AutoML pipeline and its key components. So these are the normal standard key components. First one is raw data, data preparation and feature engineering, model selection and hyperparameter tuning, model evaluation and analysis. And next is performance. If the performance okay, then it will go to the model deployment, or else it will again train and do all the processes until it reaches the optimal model. That's all about the AutoML pipeline and their key components. Next, we move to the next topic, the taxonomy of AutoML. In this taxonomy of AutoML, like AutoML system based on different taxonomical criteria, differentiates between the levels of automation in an ML pipelines, and it also compares and contrasts model-based, search-based, and evolutionary approaches to AutoML. Analyze the trade-offs between different architectural paradigms, example full pipeline versus model-centric. Identify the appropriate taxonomy category for popular AutoML frameworks. Next is what's the introduction about. These are all from the previous things which we have discussed, and which consists of AutoML process as a sequential pipeline. And but not all AutoML tools are created equal, and they have different category characteristics and different purpose which for which they have created. And some just tune models while others build the entire pipelines from scratch. That is how they work. And also they can how can we systematically classify and understand different tools, like this is where the taxonomy becomes essential. And also like core content, the AutoML taxonomy, we can classify AutoML systems along three primary dimensions. One is stage automation and technique or methodology, and third one is architectural paradigm. Visualize this as a three-axis diagram or a hierarchical tree. or the taxonomy by stage of automation, like this is the most intuitive classification based on which the part of the ML pipeline is automated. And this is a flow in how it is created, like AutoML by stage, and one is partial automation assistive tools, and full pipeline automation end to end. So if it's a partial automation assistive tools, it has hyperparameter optimization HPO and neural architecture search NAS, and next one is feature engineering automation. And in the full pipeline automation end to end, which is complete cache, combined algorithm selection, and HPO. So it's all three combined. So, which is partial automation? Like in this partial automation, hyperparameters automation tools focuses on automate only the hyperparameter tuning for a single pre-specific specified models. An example: Optuna, HyperOpt, SkyKit Optimize. An analogy like a robotic arm that perfectly tunes the knobs on a specific complex machines. Neural architecture search NAS focuses on automate the design of artificial neural networks architectures. This is the AutoML of the deep learning world. What is searches for? Like it searches for number of layers, types of layers, convolutional, recurrent, connections, or activation functions. Example like Google's AutoML Vision, TensorFlow models, optimization toolkits. These are the examples for the same. And automated feature engineering focuses on automatically generates and select the most relevant features. Example feature tools, TS Fresh for time series. And full pipeline automations like end-to-end AutoML focuses on automates the entire process from raw data to a deployable model. This includes data cleaning, feature engineering, model selection, HPO, and evaluation. It tackles the cache, combined algorithm selection, and hyperparameter optimization problems. Example H2O AutoML and Depot and AutoScaLearn, Google Cloud AutoML tables. So analogy like the full autonomous car that handles navigations, steering, and obstacle avoidance from a point A to point B. And B is taxonomy by technique or methodology. In this classifies system based on the underlying algorithm used for the search and optimization. Search-based methods, a core idea that treat the problem of finding the best pipeline model as a search through a vast space of possible configuration. Subcategories: grid search and random search and evolutionary algorithmic genetic programming. In this grid search, exhaustive search over a defined subset, simple but computationally infeasible for large spaces. And random searches randomly samples configurations, surprisingly effective and a strong baseline. Evolutionary algorithms and genetic programming. In this mechanism, like inspired by natural selections, a population of pipelines individuals is evolved. The fitted best performing pipelines are selected, crossover combined, and mutated to create a new generation. Strength: good at exploring complex, non differentiable search spaces. Example Teapot uses genetic programming. Model based optimization, Bayesian optimization core idea, the most popular and effective method of for HPO, hyperparameter optimization, and cache. And mechanism to build a probabilistic surrogate model. Example Gaussian process, tree Parison estimator TPE to approximate the expensive function that maps hyperparameters to model performance, and use an acquisition function. This example like expected improvement EI to decide which hyperparameters to try next by balancing exploration, trying uncertain areas, and exploitation, trying areas known to be good. Why it is powerful? It uses past evaluation results to make the intelligent guesses about future, requiring fewer iterations than random grid search. Example: autoscaling and scaling hyper opt SMAC 3. Reinforced learning based methods, like a reinforced learning agent learns to select actions. Example, which layer to add next, which hyperparameters to set to maximize the reward. Example, validation accuracy. Primary use, heavily used in neural architectural search NAS. Example, early versions of Google NashNet. And taxonomy by architecture paradigm, like the structures. This describes how the AutoML system is structured to solve the problem. Full pipeline constructions approach that, like in this approach, the system dynamically constructs a complete ML pipeline from a set fundamental building blocks: computers, scalars, feature selectors, models. Advantage: highly flexible, can discover novel and complex pipeline structures. Disadvantage: the search space is enormous, making it computationally very expensive. Example Teapot. Model selection and ensembling approach. The system focuses on selecting the best model from a predefined fixed portfolio of algorithms and then creating an ensemble example, stacking blending of the top performers. Advantage: more computationally efficient than full pipeline construction. Ensembling often leads to robust performance. Example: H2O AutoML trains a stack example of the best models. AutoScaler uses ensemble selections from a portfolio of models. Synthesis like classifying real-world frameworks. Interactive table on the board. Let's classify some popular frameworks together. Like in this thing, what you can see is like what are the frameworks. The frameworks are Optuna, Teapot, H2O, AutoML, AutoScaler, Google Nash, and the primary stages, primary techniques, primary paradigms, like you are going to categorize on that. The Optino partial HPO and primary techniques, model based Bayesian optimization, and Teapot full pipeline evolutionary genetic programs, and full pipeline construction, and also H2O AutoML, a pipeline full pipeline search based random grid or ensembling. In this, model selection and ensembling is a primary paradigm, and auto and full pipeline model based Bayesian optimization plus ensembling, and model selection and ensembling, and Google Nash, partial Nash reinforcement learning. So that's all about the taxonomy of AutoML pipeline. The most advanced full pipeline AutoML systems like AutoScaler uses a hybrid approaches, combining Bayesian optimization for efficiency with ensembling for performance. And benefits of understanding the taxonomy, like informed tool selection, and it also helps in research and development, program, problem diagnosis. These are the benefits if you understand the taxonomy of AutoML pipeline. And that's all for today. Thank you all for joining.